We began our discussion on linear relationships by looking at a class participating in a walkathon, and we initially looked at their walking rates, or how fast each person could walk in a given amount of time. We're going to extend our thinking on linear relationships, and we're going to continue our story with the walkathon, but today we're going to focus on the pledge plans, or the ways that the students decided to collect the money for their walkathon. So today we have the same three students giving us their information and how they plan on collecting from their sponsors. Leanne has decided that her sponsors are going to pay $10 to her regardless of how far she walks. So if she walks 0 kilometers, they're going to donate $10. If she walks 5 kilometers, they'll donate $10. Her distance doesn't matter here. Gilberto's sponsors are going to pay $2 for every kilometer that he walks. So they're not paying him anything unless he walks at least 1 kilometer. And then Elena's sponsors are going to give her $5 up front. So they're going to start by paying $5, but then they're going to add 50 cents for every kilometer that she walks. So just like we created tables for each person's walking rate, we're going to do the same thing today for each person's pledge plan. So we'll start with Elena. Now remember, Elena's plan was that every sponsor would give her $5, and then they would add 50 cents for every kilometer that she walks in the walkathon. So in her table, that means that even if she doesn't walk a single kilometer, her sponsors are going to give her $5. But as soon as she walks 1 kilometer, they're going to add 50 cents to that. So now she gets $5.50. And then if she walks 2 kilometers, well, then they're going to add yet another 50 cents, so that's $6. And so forth down the table. So every time she walks another kilometer, she gets another 50 cents on top of that $5 up front. Now remember, in our last lesson we talked about where the independent variable is in a table and where the dependent variable is in the table. Remember, our independent variable is the left column. And in this case, the independent variable is going to be the distance that a person walks, because the distance that a person walks determines how much money is collected. The money collected depends upon the distance, so the dV becomes the money in this case. All right, so we're going to follow the same expectations. We're going to stop the video here, give you a minute to think about the pledge plans for Leanne and Gilberto. Complete a table for each of these students. Now remember to ask yourself, how much does each person initially get from their sponsors? And that would be how much they get at 0 kilometers. And then how much is each sponsor adding for every kilometer that the student walks? When you think you have the tables, restart the video and check your work. Okay, so let's start by looking at Gilberto. Now remember, he was collecting $2 for every kilometer walked. So if he doesn't walk a single kilometer, he doesn't get any money. But as soon as he walks a kilometer, his sponsors will pay $2. And once he walks $2, then he doubles that, he gets 4. 3 kilometers will give him $6, and so forth and so on, all the way up to 10 kilometers, earning him $20 from a sponsor. Now Leanne's plan was that she would just collect $10 from each sponsor for her participation. So that didn't depend, her money didn't depend on how many kilometers she walked. So even if she doesn't walk a kilometer, her sponsors are donating $10. And as soon as she walks 1 kilometer, well, they're not adding anything to that. They still donate $10. 2 kilometers is not going to get her anymore. She gets a flat $10 from each sponsor for her walkathon. So like we did in the previous lesson, let's go ahead and take this data and get a picture of what's going on. Let's graph all this information. Now I want to start with Gilberto's pledge plan. Now remember, the IV, the first column, is what goes on the x-axis. So you'll see that we have the distance down here in kilometers. Always remember to give your units. Our DV, the money collected, which is in the second column, is over here on the y-axis. And we have a title for the graph that kind of goes along with our scientific thinking, the effect of the IV on the DV. And then we can use the data from this table as coordinate pairs. So at 0 kilometers, Gilberto's not getting any money. At 1 kilometer, Gilberto's going to get $2. 2 kilometers is going to get $4 from a sponsor, and so forth and so on. Then we're going to take a ruler or a straight edge and connect those dots. And then we can see that linear relationship on our graph. So this is a graph of Gilberto's pledge plan. We can use this graph just like we could use his rate to determine how much a person would donate for any given distance that he walks. All right, it is your turn now. Stop the video again. Graph the data for the tables from, not Gilberto, we've already done that, but from Elena and Leanne. Use different colors, use a straight edge. Once you have these graphed, restart the lesson and check your work. All right, so this is the graph we should be looking at. You may use different colors, but your lines should be the same. The data points should match up. On Elena's pledge plan, that line in red, remember she starts off by getting $5 from every sponsor and then 50 cents for every kilometer that she walks. And Leanne's pledge plan is up here at the top. She gets $10 regardless of how far she walks, so she has a horizontal line going across the top here. Again, make sure you have all the labels for your scales, make sure you have a title, and make sure you use a key to help your reader understand which color represents each student. So now we'll move on and write some equations for each pledge plan. And we'll start with Elena. It helps us to understand our equation if we can put in words what each part of our situation is representing. Our IV in this case is our distance in kilometers. Our DV is our money. And our rate is a comparison of the two. Remember, the rate is how much money a person is getting for each kilometer that they walk. And then the starting point is how much each donor is giving up front. Before a person walks a single kilometer, how much is each sponsor giving? So in our table, let's come down to the second row now and decide what we're going to use to represent each of these situations. Now sometimes we have a variable, sometimes we have a number. For our IV, our independent variable, since that can change, we go from 0 kilometers up to 10 and we can go beyond that. Let's use a variable, something that can change as well. And let's use a D since we're talking about distance here. You can use X if you like. A lot of mathematicians use X and Y. It's up to you. Our dependent variable is the money collected, so I'm going to use an M in this case. And then the rate, that's staying the same for Elena. She gets 50 cents for every kilometer walk. So here we can actually use a number. We can use 0.5. We can use 1/2 if we like. But that's not changing. They give them 50 cents for every kilometer. And our starting point, every sponsor was giving her $5 before she ever even started the walkathon. All right, so we can put this together now. We can think about this. Elena's equation, her money was determined by how much money each donor gave up front, or $5, and then add to that 50 cents for every kilometer walked. So we have an equation of M, money, equals $5 plus 50 cents times D. All right, let's look at this very carefully, and then it's your turn. Use the tables that you have in front of to help you organize your thinking. Write the equations that represent the pledge plans for Gilberto and Leanne. Remember to think carefully about the four important parts of this. The DV is the money collected. The IV is the distance walked. The rate is how much money they get per kilometer, and the starting point is how much each sponsor gives before they begin the walk. Stop the video, write your equations, fill in your tables, and then check your work. All right, in front of us we have the table for Gilberto's equation, and I used X and Y in this case just so you could see how this works. I'm going to use X to represent the distance walked, Y to represent the money collected. The rate is $2 per kilometer, or just 2. And they don't give him anything up front, so the starting point is 0. So when we put this together, we have that the dependent variable, or Y, is equal to $2 times the distance walked plus nothing up front. Now sometimes you won't see mathematicians write that plus 0, so you might see it written as Y equals 2x. You may have chosen to use D for your independent variable and M for your dependent, in which case you would have M equals 2D, and that is fine. It's the same equation, just different variables. Now Leanne's equation was a little bit different. I still used X for the independent variable and Y for the dependent variable. But as far as the rate goes, they didn't give her any extra money per kilometer. So that would be 0 for us, nothing extra. However, they started off by giving her $10. So our equation for Leanne looks like Y equals 0 times the distance walked plus the $10 up front. Now because 0 times any number is 0, sometimes you'll see mathematicians simplify that equation to Y equals 10. So the important thing for us to understand about this equation, we use the same thinking that we used in the first lesson, where the dependent variable was equal to the rate times the independent variable, but this time we had some starting points to add to that. Now in mathematics, mathematicians have a general rule or a literal equation that represents this relationship, and you see that in front of you, where Y equals mx plus b, where Y is the dependent variable, M is that rate of change that we've been talking about, X is the independent variable or the input, and B is the starting point. And it's nothing to be worried about. It's just variables that mathematicians choose to use about these relationships that you've already investigated. So before you move on from this lesson, be sure that you can create a table for a story based on a rate of change. Make sure that you can take that table and create a graph for that linear function. This time we need to be able to identify the IV, the DV in our tables, our graphs, and our equations. And we need to be able to write an equation for a linear relationship in the form of Y equals mx plus b. So when you finish this, check in with me, see what questions you have, let me help you with any uncertainties, and then you'll be ready for the independent practice.